Hello students, now let us try to understand the thermochemical equation. Okay student, so how can you be able to understand the thermochemical equation? So in thermochemistry, the equations which we are going to study is known as thermochemical equation. And the chemical equation in which heat change accompanying a reaction is also numerically specified with the proper sign, that is delta H or delta U, by the side of the equation is known as the thermochemical equation. Okay, again you read out the term. The chemical in which heat change accompanying a reaction is also numerically specified with the proper sign of delta H and delta U by the side of the equation is known as thermochemical equation. So means any thermochemical reaction where the heat is evolved or released is known as what? Thermochemical reaction. Okay. What the next paragraph, student? In these equations, the physical state of the reactants and the products are also mentioned in the brackets by the symbol. So when you are writing the thermochemical reaction, we have to mention the physical states of the reactants and product, whether they are solid, liquid or gas. Okay. Allotropes will also be mentioned. Whatever the allotropes is there, like the carbon graphite is there, that has to be mentioned. Phosphorus red is there, phosphorus white is there, that also we have to mention. What type of sulfur is there, monoclinic sulfur is there or rhombic sulfur is there, we have to mention the allotropes of the particular reactant. The enthalpy of an element is in its standard physical state is fixed at 0. Actually, enthalpy cannot be determined. What they are saying, that is enthalpy in standard states will be 0, or in another word you can say standard enthalpy cannot be determined. Okay, so standard enthalpy of the any element is fixed, and that is what? 0. Gases H2O2 N2 F2 Cl2 inert gases. Okay, so these are gases H2O2 N2 F2 Cl2 are inert gases. Liquids are Br2 and Hg. So mercury and bromines are liquid. Solid, all metals. Iodine is also the solid. If the element exhibit allotropy, the enthalpy is fixed at 0 for the most stable and most abundant allotropes of the element, that is enthalpy of the allotropes of the element is 0. The standard condition for the chemical reaction, temperature has to be 25 degrees Celsius, that is 298 Kelvin, and pressure has to be 1 atmospheric pressure, that is 760 mmHg, and 1 bar pressure. The physical state of the substance under standard condition, that is 25 degrees Celsius and pressure 1 atm, is known as standard physical states. Okay, so that we have to keep in mind, that is at the standard temperature conditions, temperature pressure condition, the enthalpy must be, or then whatever the enthalpy is coming, that is what is standard enthalpy is known as. In the standard state, the enthalpy of the element is 0. For example, chemical species is there and standard enthalpy is given. So H plus enthalpy is 0. Element in the standard state 0. Reference allotrope 0. Compound never 0. Next one is there reference allotrope. Carbon graphite is 0. Phosphorus white 0. Sulfur rhombic 0. Arsenic gray 0. Beta tin. Okay, white tin, that is also 0. So they are the allotrope. They are having the 0 enthalpy, standard enthalpy. Factor affecting the heat of the reaction. Factor affecting heat of the reaction. The heat of the reaction depends on physical state of the reactants and product. Physical state of the reactants and product. Okay, that is affect the heat of the reaction. H2 plus half O2, that is H2O. Okay, here is gas and liquid. So delta H is minus 285.6 kilojoule. And when H2 plus O2, it is forming H2O gas, and here is liquid. So enthalpy is how much? Minus 241.7. So it is liquid formation, the enthalpy is very high. Okay, released enthalpy, that is the energy released, is high, is 285.6. But if it is the gaseous state, it is the less, to minus 241.7. What is the stoichiometry of the equation? Also the change the enthalpy. So what is the H2 plus O2? It is giving H2O liquid. Here is minus 571 71.3 kilojoule per mole. And here you see stoichiometry is 2. If the stoichiometry is 1, so here is the enthalpy is how much, student? That is 285.6, that is half of that. Allotrope also change the enthalpy. Carbon graphite plus oxygen CO2, enthalpy is minus x. Carbon diamond plus O2, that is CO2, enthalpy is minus 1. Where if where y greater than x, y greater than x, so means diamond having more enthalpy than the graphite. And what about the pressure? Q is equal to P, QP, that is delta H is equal to delta RH as constant pressure and temperature. At Q is equal to QB is equal to delta E is equal to delta RE at constant volume and temperature. So this is what is, that is at constant pressure, that is it is known as what, enthalpy. And at the constant bottom, which is known as what is, student? It is internal energy. That also you have to keep in mind while solving the problem. Next one, what is the relationship between the delta H and delta U for particular reaction? For any chemical change, reactions at any constant temperature, delta RH is equal to delta RU plus delta NGRT. T is absolute temperature of the reaction, R is universal gas constant, and delta Ng means delta Ng number of the product, gaseous product minus gaseous reactant. Okay, number of gaseous reactant. For any process which does not involve gases, is delta H is equal to delta U. For any process which does not involve gaseous, okay, gases, that delta H is equal to delta U. If delta Ng is equal to 0, then delta H is equal to delta E. Okay, that is work done is 0. So enthalpy and internal energy will be same. Delta U including the sign. Okay. Next one, if delta Ng is less than 0. Okay. If delta Ng is less than 0. So that is, then internal energy is more than enthalpy. That is U including sign. If delta Ng is more than 0, then the delta H will be more than delta E, and that is U internal energy including sign. For example, C2H4 plus 3 CO2, it is giving 2 CO2 plus 2 H2O at 25 degrees Celsius. So delta U is equal to, it is the negative sign of 13.90.5 kilojoule, and delta H is also, that is minus 13.94.1 kilojoule. So that is here what you are finding, that is number of gaseous product are more than the gaseous than the reactant. So that is why that is delta H is more. Concentration of solution, if any, that also affect. Temperature of the reaction also affect. If the temperature and the heat of the reaction can be explained by Kirchhoff equation. Let us see. If Cp of the reactant and products and temperature are independent, so delta RCp is equal to Cp product minus Cp reactant equal to delta H2 minus delta H1 upon T2 minus T1. For example, here it is given for N2 plus 3H2 is equal to 2NH3, it is delta H is given minus 91.88 kilojoule per mole and 92.80 kilojoule per mole. And delta Cb is equal to, that is delta Cb is equal to number of Cb product and minus reactant. So delta E2 minus delta E1 is equal to divided by T2 upon T1. So this is what the thermochemical reaction, student. There are some conditions are there that we have to keep in mind while solving the problem, that we have to keep, that is if the standard states are there, any elements are present in their standard state, so enthalpy will be 0. If that is allotrope is there, then again the enthalpy will be there. And always the reaction we have, whenever you are writing the thermochemical reaction, you have to mention the thermochemical reaction with the phases of the reactant and product, that is whether they are solid, liquid or gas. And in another word, another things are also, we have to maintain the coefficient also, and then we have to calculate, that is the enthalpy, internal energy. And how we are calculating enthalpy? Enthalpy we are calculating, that is enthalpy of the product minus enthalpy of reactant, and the same way enthalpy of the internal energy of change means internal energy of the product minus internal energy of the reactant. So this way, number of gaseous product minus gaseous reactant, we all have to, everything we have to calculate, and we have to keep in mind, that is what is the standard temperature, pressure. Standard temperature is 25 degrees Celsius equal to 298 Kelvin, and that is standard pressure is 25, that is standard pressure is, that is 1 bar pressure, or 760 mmHg, and or you can say that is 1 bar pressure. So this is all about the standard temperature pressure that we have to keep in mind while solving the problem. Thank you so much for watching, friends.